In this presentation, we will go around the LPG stove and the cylinder to find out how the system works. Let us go back to the college days when we were using the Bunsen burner in the chemistry laboratory. The flame pattern of the Bunsen burner has got different shapes and sizes as given in this diagram. When the air to the burner is less, it becomes sooty, still increase, it becomes yellow, and when you have adequate air, you get a roaring blue flame. Now let us see the LPG burner. Here also we can see a perfect blue flame. And there are small flames coming out of the individual holes in the burner tip. This indicates that each burner hole gets sufficient excess air for burning. Now the question is, who is giving this excess air and where is it given? It goes without saying that since all the small flames are perfectly blue and are identical, the air has been given much ahead of the burner tip. Let us now analyze how an LPG burner works. The LPG vapor comes into the burner through a small nozzle in the front. The area of the nozzle is very small and this will increase the velocity of LPG vapor. When the velocity is very high, according to Bernoulli's principle, the pressure becomes very low. It goes to subatmospheric levels. So, the air from outside sees a potential for flowing inside according to Hagen-Poiseuille equation. So, the air gushes in through the aspirator holes on the sides. The air and LPG mixture will flow forward through a cone where pressure recovery takes place. Pressure becomes positive again so that it can come out through the holes in the burner tip. Explaining once again, the gas comes at very high velocity in this restricted area, so the velocity increases, pressure reduces, air from atmosphere will enter the burner, mixes, and there is an expansion zone where the pressure comes back to positive side. Otherwise it cannot come out of the burner. Kindly understand that LPG in the cylinder is in the liquefied form. That's why it's called liquefied petroleum gas. Now, it's not full of liquid. A part of the cylinder, that is the space at the top, is gas. When we open the cylinder valve, it's actually the gas coming out and going through the nozzle. If liquid comes, you had it. So it's mandatory that you should keep all the LPG cylinders vertical. As we start burning in the LPG burner, gas from the top of the LPG cylinder is removed and hence the number of molecules in the top space will come down. Since PV is equal to nRT, since N comes down, the pressure has to come down. So gradually the pressure inside the cylinder tends to fall. But this cannot fall down because of the equilibrium existing between LPG, liquid and vapor. So as per the equilibrium, some LPG has to necessarily vaporize and maintain the pressure. This is easily said than done, because for vaporization you require latent heat. Initially, the latent vaporization is taken from the liquid itself, and the liquid inside the cylinder cools. This is why when you touch the cylinder sides, you feel little cold. When the temperature of the cylinder has fallen sufficiently low, there is a driving force between the atmospheric air and the cylinder inside, which forces heat to be transferred into the cylinder. So that gives the source for the latent heat further.